Hello my dear students, now I will give you a lesson on divergence theorem that has a broad interest in our electromagnetics field. We have talked much about the importance of divergence theorem and Stokes theorem. So you can see here there is a rule that how we can calculate and derive some of the issues related to the divergence theorem. So that first of all you have to know what is the divergence theorem. The divergence of a vector field is a net outward flux per unit volume. Okay, that is divergence. When delta is a scalar dot product of a vector, it is known as divergence. And the divergence theorem means the volume integral of this kind of divergence. Volume integral of this kind of divergence is equal to the total outward flux of the vector through the surface that bounds the volume. That means that is a surface integral. It will be the surface integral, bounded surface integral. That means a circle created in the integral sign, that is known as the bounded integral. That means the integration will be bounded, or it has some limits. Okay, so surface integral is, that is the vector, and that is the dot product, and also d of s, and it has also a vector because we have used here a bolt sign. That means that is also a vector. So the thing is that the volume integral of the divergence of a vector field equals the total outward flux of the vector through the surface that bounds the volume, that is this. And eventually we can say which will be proved in the following paragraph, that is called known as the divergence theorem, and it applies to any volume V that is bounded by the surface S. The direction of ds is always that of the outward normal perpendicular to the surface ds and directed away from the volume. So how can we understand this? First of all, you have to take a matter like this. It's the one kind of matter, just it has no other shape, just it's a matter. Okay, in this matter that's the boundary that I have directed to the arrow sign. This is the boundary of the matter, and in the upper side, that is the surface of the matter. uh, for your kind information and your uh, understanding, I am changing the color of the patterns. Now you can see this is the surface. Okay, this is the surface. This is the surface that I have drawn in the blue. The red color is the boundary, and if we just think there is some electric field that are going through to this surface perpendicularly, like that, we can write that, we can just draw that. This is the electric field, direction of the electric field, and this is the ds. The direction is like that, the ds is that. Okay, and the surface bounded through in that arrow direction. Now uh, we can see that is the electric field E. Actually, the direction is from this direction to that, and the divergence theorem is that the bounded integral, that is the bounded integral, that is the boundary, I guess, the bounded integral of the volume. Okay, the total volume of the flux, that is the divergence of the vector. So we can get this equation to that rule. That is the theorem of divergence theorem, and we will use in the next mathematics that we have done in before. I have told you before, but I didn't explain you the theorem at that time, but I have used before some lectures on Gauss's law derivation. You can see in previous lectures. Now coming back to the point of divergence theorem to the Stokes theorem, what is now we can use the Stokes theorem. Now we will go forward to the Stokes theorem. Okay, Now we are heading towards the Stokes' theorem. What is the Stokes' theorem? First of all, we have largely used divergence theorem. That means the divergence of a vector, the scalar product of the vector. But now, if we heading towards the point that the curl of a vector like that, if we integrate surface integral of the curl of a vector is the bounded, that is a bounded integral of line integral. We can get the line integral through this. That is known as the Stokes' theorem. Now that we have to understand the Stokes' theorem by words. That how can we now understand by the words? That is the equation of the Stokes' theorem. Now we will get the point from the statement. That is the statement: the surface integral of the curl of a vector field over an open surface is equal to the closed line integral of the vector along the contour bounding the surface. So that is the thing. If the surface integral del cross A is carried over a closed surface, there will be no surface bounding external contour. What is contour? The contour is a bounded circle, just like this. You can see here there is a figure. That is one of the matter that we are calculating the surface contour. We have divided many parts in this surface, and there are a very small surface. There is a circulatory surface we have found here. ds we know the vector from a simple surface to the normal of the surface. That means that will be perpendicular to the surface. Okay. Here you can see there is a c. C means the line integral of closed surface contour. That is closed surface contour. Okay. The curl of a vector, surface integral. If we just integrate in this surface, in this bounded surface, so we can get the vector. We can get the vector with the surface contour. The line is that. Now we can read again. Closed line integral. Closed line integral. That is the closed line integral of the vector along the contour bounding the surface. That means the area that bounds the surface. The area that bounds the surface. So the surface integral of the curl of a vector, the surface integral, the surface integral, the surface, there is a surface, there is a surface, surface integral of the curl of a vector, just like this, surface integral of the curl, that is the curl, that is the curl of a vector, that is the curl of a vector, that is known as curl. The cross product of a vector of a del vector is known as the curl of a vector, that is ds, because of surface integral curl of vector field over an open surface, that is an open surface, that is an open surface, is equal to the closed line integral, is equal to the closed line integral, that is the sign of a closed line integral, c of a contour, closed line integral of the vector, that is line integral, so that will be dl, closed line integral along the contour bounding the surface. That means a, again the dot product will come. Okay, we can just now yes, that's the dot product. That's closed surface integral that has been covering the L, that is dl. Okay, the total thing is the scalar, and that is dl is also a vector sign. Okay, so that is the two things of Stokes' theorem and divergence theorem. Okay, so last of all, if we want to convert a volume integral to surface integral, we will use divergence theorem, and if we want to convert surface integral to a line integral, we will use Stokes' theorem. That's the main theory of Stokes' theorem and divergence theorem. Thanks to all for being with me.